Hello everyone. So in this video, we will learn trigonometric functions. We have 6 trig functions. So we will use SOHCAHTOA to find right triangle side length. Okay. It is very easy to find third side of right triangle. I will show you how you will find your answer in seconds. Okay, it's very simple to use it. So I will show you that method, and next I will show you some special triples. So if you memorize that special triples of right triangle, then it will really just take seconds to figure that out, your answer. What is my third side of right triangle? Okay, very good. So let's start. So here, first thing, when we can use this SOHCAHTOA. So first condition, if we have right triangle, we can use this SOHCAHTOA. Okay, and what is this SOHCAHTOA means? So here we have 3 different functions. So S, that means sine. All right, S, that means sine function. C means cosine function, and T means tangent function. All right. So another 6 function, we can just use this 3 function to find out other 3 because those are reciprocal of sine, cosine, and tangent. So I'll show you that as well. So what is sine function is? It says OH. OH, that means opposite over hypotenuse. So we can see here sine, let's say we have sine theta equal OH. O stand for opposite and H stand for hypotenuse. All right, so next we have cosine. We have cosine, C for cosine. So we have cosine is, see we have A and H. A stand for adjacent. So I can say adjacent over hypotenuse. And third function we have is T, T for tangent. So I can say tangent theta equal. It says O stand for opposite over A is adjacent. So we can, here I set theta. So you need to memorize this. But how you will memorize? By just this sentence, like SOHCAHTOA, right? So you can just remember that. So let's see in this triangle how we will use that. So first thing, do I have right triangle? Yes. So let's say I need to find for angle B, all right, angle B. So first thing I need to know what is my hypotenuse, what is adjacent side, and what is opposite side. So first thing I recognize this right triangle. So that is right angle. Opposite of that right angle, that called hypotenuse. And we need to find for angle B. So what is next sides to this B? Which one is closest one? This one. So that one is adjacent. And what is opposite side? What is opposite side from this B? So if you will draw this arrow, or you can keep your finger, or you can keep your pen to that arrow. So you can see that is your opposite side. All right, so now we can find sine function. Let's say we have sine B equal. Sine B equal. It is SOHCAHTOA, right? So you can write on a top, you can say so OH. O is opposite. What is opposite side? B. And hypotenuse is what? C. So that's how you find sine function. Let's see other one we have. We have cosine. So we need to find cosine B. So cosine B, so C-A-H. H, A is adjacent and H is hypotenuse. So we will get A over C. See, that is your hypotenuse. adjacent, and C is hypotenuse. And third function we have is tangent. So tangent B is, we have function is tangent SOHCAHTOA. So O stand for opposite, which is B, and A stand for adjacent, which is A. So here we found three functions, right? Three functions we found. Now, what is other three functions are? So we knew cosec cosec B is reciprocal of sine B. So you will just do opposite, reciprocal of B over C. So you will get C over B. Secant and cosecant, they are reciprocal of each other. So we will get C over A. And tangent and cotangent, they are reciprocal of each other. So we can just do reciprocal of B over A, which is A over B. So here we have 6 functions we can find from this SOHCAHTOA. Okay. So we will use this rule to find third side of right triangle. So let's see here we have, okay. So let's see, we have right triangle here, and I have in triangle A, B, and C. Let's say we have this length is 3, here is 4, and I don't know what is this length is, right? But I had to find 6 trigonometric function value as well: sine, cosine, tangent, cotangent, secant, and cosecant. So before we will find 6 function value, I have to find third side of this length. So how we will find this? So we have right triangle, so we can use Pythagorean law. What is Pythagorean law? Is we have one leg, which is 3 square. Second leg, we have 4, which is 4 square. And this we don't know, we can say x square. So 3 square is 9, plus 4 square is 16, x square. 9 plus 16 is 25, which is x square. So now we can do square root on both sides, so which is 5. So x is 5. So we can write 5 here, right? So we have this right triangle, we have each side length. Now we can use SOHCAHTOA and find 6 functions. So we have 3 here. We have triangle A, B, and C. We have right angle right here, 3, 4, and 5. So let's say we need to find for angle A. We have to find 6 functions. So sine A, cosine A, tangent A. And then you can find cosecant A, secant A, and cotangent A. So how we will find it? Sine A. So SOHCAHTOA. So you can write on a side. We have SOHCAHTOA. Right? So we have S for sine, C for cosine, and T for tangent. So sine A, opposite over hypotenuse. So we have angle A we are looking for. So what is opposite? Opposite is 3. So that is opposite. And what is hypotenuse? So in front of 90 degree we have 5. So that is hypotenuse. And this side is adjacent. So 3 over 5. Cosine A, adjacent. See, we have adjacent over hypotenuse. So we have 4 over 5. And tangent is opposite over adjacent. So we have 3 over 4. And then we can find these other three functions, which one are reciprocal of each other. So sine and cosecant, they are reciprocal. So we will just reciprocal of 3/5 is 5/3. Secant and cosecant, they are reciprocal of each other. So we will just do reciprocal of 4/5, which is 5/4. And next one we have tangent and cotangent, they are reciprocal of each other. So we will get 4/3. So that's how you can find 6 functions from this right triangle. So let's see here. Now we have, let's see one more example. We have right triangle. We have right triangle here. And I will give you, let's say we have triangle A, B, and C. I will give you exactly same triples, 3, 4, and 5. And now this time I will find for angle C. All right, let's see what will happen from here. So we will use again SOHCAHTOA. We have right triangles, so yes, we can use SOHCAHTOA, and we will find 6 functions of trig. So sine C, cosine C, tangent C. And then we will do cosecant C, secant C, and cotangent C. All right, so you will write down again each time when you do homework, write down SOHCAHTOA, so you will memorize end of your homework or practice problem. So let's say SOHCAHTOA, right? So sine is here, sine C. We are looking for this angle. So what is opposite side? Opposite side is 4. And hypotenuse is 5. So sine C is 4 over 5. Cosine C is what is next to this angle is, this is adjacent side. So we have 3 over 5. And tangent C is opposite over adjacent. So we will get 4 over 3. And then here you will just do reciprocal. So you just flip it. 5 over 4, 5 over 3, and here 3 over 4. All right, so now what we can notice from here, so see we have exactly same triangle. If you will notice from this, we have sine A is 3/5. So if you will check cosine C have same value. Look at that. If you will check here, we have cosine A is 4/5. And we have sine C is 4/5. So cosine and sine, they are co-function, okay? So I will explain to you in next video how we will decide co-function. It will just take 1 second to do it, okay? In SAT test, they ask you co-function, the SOHCAHTOA, special triangle, 30, 60, 90 triangle, in 45, 45, 90 triangles. So we will do in next video. So I will show you, but you can notice from here, okay? So now we can see some special triangle. So what is special triangle is, if you have one side is 3, 4, and 5. So we have special triples here. You can memorize that. It will help you. It will save a couple seconds for your SAT test. So we have 3, 4, 5. Next one we have 5, 12, and 13. And also whatever longest side, that must be hypotenuse, okay? Next one we have is 8, 15, and 17. Next one we have 7, 24, and 25. Next one we have 9, 40, and 41. And we have one more, we have 11, 60, and 61. Now another thing what you can do is, so we can make plenty of this. So let's see, I'm gonna multiply to here any constant. So multiply by 2, multiply by 2, multiply by 2. So if you have one side, one leg of right triangle is 6 and other is 8, then next hypotenuse must be 10. If you are multiplying by 3, then you will get 9, 12, and 15. You can multiply by any constant and you can create another pair of triangle sides, right triangle sides. Same thing, all of that. Okay, so let me show you one more. Let's say I'm multiplying by 2 again. So 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. So you can remember these triples and use this to find third side of right triangle. Okay, so this is very, very helpful for your SAT test. So try to do more practice. Use SOHCAHTOA whenever you will do homework. Keep writing SOHCAHTOA, so end of the session you can memorize this SOHCAHTOA rule. And if you have any questions, let me know. You can write in a comment. Everyone is watching video, that's good. Make sure you will watch my next video, will be special triangle 30, 60, 90, 45, 45, 90 degree, and co-function video. All right, and subscribe my channel. I hope this video will help you. Thank you very much.